All right, so for this video, we're going to be looking at electron configuration, and this is what you're going to have to be able to do in order to get a 5 on the drawing the atom part for the summative. So a lot of you got 3s and 4s on your formative, so I'd like a lot of you to really use this as an opportunity to push for those 5s, push to go from those Bs to those As. So what's going to happen? The first thing you're writing down on your note sheet is, what is electron configuration? Why is this important in chemistry? So electron configuration is a bit of a shorthand, or like an easier way to write things. Remember, chemists are lazy. And it's a method of showing the arrangement, so how electrons are kind of organized around the nucleus. Okay, so it's a shorthand way of letting us know where are these electrons located and what does it look like. So I'm drawing an example of lithium right here, and you can see that lithium has 3 electrons, 2 in the first ring and 1 in the second ring, and that electron configuration actually lets me know what that looks like without having to draw the atom. So the next thing we want to look at, what does electron configuration even look like? And so I showed you the example with lithium. We're going to do a really easy example here of helium. So the 1 in the front represents the energy level. Okay, the 2 represents what the orbital type it is. There are different shapes for orbitals. They're not always just circles. You have the S, P, D, and F orbitals. Okay, and that superscript of a 2 lets us know the number of electrons in that orbital. Okay, so from this electron configuration, I know that I have the first energy level. So from the nucleus, I'm in my first ring. I know that it's a circle because that's my type of orbital, and I know that I have 2 electrons in it. Okay, so I know from this is helium. Okay, so it's just a shorthand way of doing it. So moving forward then, we have to know how to find those energy levels, because that's the basis of knowing how many rings we have filled up. So it looks as such. So I'm going to pause this really quick here. On our farthest left is where we have our first energy levels. So 1, 2, 3, 4, 5, 6, and 7, and that just goes down with the rows. Notice that we moved helium over. Okay, then the next go across, starting with boron, and those are going to be our 2, 3, 4, 5, 6, 7, and it follows just straight across here. But I recommend writing them on the middle right columns, and then our final are our transition metals, that lower block, and that's 3, 4, 5, 6. And these are the ones that don't line up because d orbitals are special. Again, that's just showing the movement of the helium. And then we have f orbitals, which are the ones on the bottom that we are not going to focus really on for this video. So then after we know how to find the energy levels, we have to be able to find out what the orbital looks like. All right, so the energy levels, how many shells are we going to have? The orbitals let us know what those shells would actually look at. So the first one I highlight is our S block. Then I highlight our D block, our P block, and our F block, okay? So, nope, go back. My apologies. So the S block is all the way to the left, and it's the first 2 groups with hydrogen, and again, we're moving our helium over. Then the middle block, the lower transition metals, are the D block. That's what you see in blue. The P orbitals are what you see in purple. And the F orbitals are what you see in yellow. And that's just letting us know what shape of orbitals those electrons live in. Okay? Then we need to know the number of electrons that can fit in each orbitals, because that's how we're going to get our superscript. So each type of orbital, S, P, D, and F, have a unique number. So the S can only hold up to 2. The P can hold up to 6 electrons. The D can hold up to 10 electrons. And our F can hold up to 14 electrons. So if you ever see a superscript for S that's bigger than 2, you've done something wrong. If you ever see a superscript for D that's bigger than 10, you've done something wrong. And a reminder, a superscript is just that little number raised. Okay? So we've kind of went over what it looks like. Now we're going to do an example because that's probably the best way to learn how to do it. So we're going to do sodium, which is Na. And the first step before you can do anything else is to find it on the periodic table. Because the periodic table to do electron configuration is kind of like playing a board game. You have to hit every single square before you can get to your end point, before you can get to the element that you're trying to show. Okay? So we found sodium, we know it has 11 electrons. So we're going to have to show that in our electron configuration. So the first thing I always do is I write down my energy levels, I write down my orbitals, I move my helium over, okay? And I know that I'm going to start with my hydrogen because I have to start at the very beginning, just like on a board game, before I can get to my sodium. Okay, so I need to start with my hydrogen and helium because they are in my first energy level before I can move on. Okay, they're like little checkpoints. So, again, I just rewrote it a little bit neater. I include my energy levels, I include my P energy levels, I circle what I'm looking for, and I know where I'm starting. So, with that, I know that my hydrogen and helium are in my first energy level. That's what I've circled on the side. Then if I look up, both of them are in my S orbital, and I have to get rid of two of them. So I have two dashes, two cross marks that exit them out, and that's something that lets me know that I have two electrons in that orbital. Okay? So I have two electrons in that orbital. So I have one S2. Again, I'm just rewriting my energy levels. You guys have the same periodic table, so that makes your life a little easier. I'm still trying to get to my sodium. I have crossed off. So I have crossed off my... So we crossed out the lithium, and so now we need to cross off the beryllium, which is how we know that it's going to be 2s2, because we have two electrons in that orbital. Okay, so we're still moving on. So we're not quite to our sodium. So now we're going to go across the periodic table to our P group to move down further. So again, once again, we write down what we already have. You guys your periodic tables stay labeled. Mine, however, do not stay labeled. So I'm just relabeling them. So now, back that up a little bit. I now am working in the second energy level for my P. Okay? So P starts with 2. Then I put a P because I know I'm in my P orbital. That's the letter above it. That's the shape of the orbital. And I'm going to do my same thing. I'm going to cross out all the elements all the elements I have to pass by in order to get to my sodium. So 1, 2, 3, 4, 5, 6. So it's going to be 2P6. All right? Now, I'm almost to where I want to be with my sodium. However, you want to land on that square. So you have to include it in your electron configuration because you have that electron there. So I have 2p6. Now, the last one I have to do, I'm crossing out all of the boxes I've gone through, and now I'm getting to my sodium. So I have 2p. Okay. I have 1s2, 2s2, 2p6, and I'm moving along, all right? I have my orbitals labeled. I know that I'm going to be in my third energy level because that's the energy level sodium is located on. I know that I'm in my s orbital because sodium has an s orbital. And however, I'm only doing one slash. I want to land on sodium, so I'm only going to have a 1 as my superscript. Okay? So now we're moving on to a second example. So for our second example, we're trying to find silicon. So once again, I'm just ordering all my energy levels. I'm labeling my orbitals. I'm making sure I have everything set to go. So of course, again, I start with my hydrogen and my helium. So the first thing that I'm going to do is I'm going to want to get rid of those hydrogen and helium so I can move on through my orbitals to get to my silicon. So hydrogen and helium is my start. So I start at energy level 1. They are in S, and I have 2 crosses, so that is S2. Okay? Then I move on. So my hydrogen and helium are taken care of. Then I move to my second energy level, so I have 2. and I cross out my lithium and my beryllium, so that's 2s2. I move across the periodic table to 2, and now I'm looking in my p orbital. I'm going to cross out as many electrons as I have. So, oops, that went a little far. We are going to do 2p6, all right? So I'm still not at my silicon yet. So I move down another energy level, and I go to my third energy level, and I am in my s orbital. I cross out sodium, and I cross out magnesium, so that is 3s2, all right? And I'm still not quite at silicon, so I go across to my third energy level for my p orbital, okay? And then I cross out as many as I need to, 1, 2. So silicon, the whole electron configuration is 1s2, 2s2, 2p6, 3s2, 3p2. So the reason I do that is because if I were to draw this, okay, so my silicon, make it nice and big, 13, oh, sorry, erase, go back, sorry, 14 protons, okay, and then I'd find my number of neutrons. My first shell would have 2 in it. My second shell would have 8. 2, 3, 4, 5, 6, 7, 8. And my final shell would have 4 in it. Okay? Instead of doing this whole drawing, which does not tell me exactly where my electrons are located, what orbitals they are working in, I instead do my electron configuration, which gives me an exact location of how many energy levels I am occupying, which I have 3 rings, 1, 2, 3, that's why we ended on a 3, okay? And how many electrons are going to be in each of those orbitals. All right? So, you have some extra practice problems, and I'm going to make shorter videos for those since this one's a little long. Once again, I'll start with the answers, so if you just want to watch the first couple seconds to see if you got it right, that's fine, but they'll also be explained.